Egypt has announced a tender for the construction of 21 new desalination plants, with 28 international consortiums bidding for the project.
Right now, millions of gallons of liquid are rushing through a secret vein buried under the scorching sands of the Sinai. It moves silently, bypassing checkpoints and political blockades. This engineering marvel appeared almost overnight. One day it was barren sand, and the next, a complex network of pipes was snaking toward one of the most dangerous places on Earth. Intelligence agencies watched in confusion. Why would Egypt spend millions digging here? The answer lies deep underground, and it involves a resource that is becoming more valuable than oil. But the risk of this pipe bursting is terrifying. Satellite images revealed a strange new line. In July of 2025, the silence of the Sinai desert was broken by the roar of engines. A massive convoy of heavy machinery crossed the border, moving with a speed and purpose that suggested a military operation. We are talking about excavators, industrial pumps, and miles of thick piping. This was not a standard construction crew. It looked like an invasion force of engineers. They set up camp and immediately started cutting through the desert floor. But here is the catch. No one officially announced what was happening. There were no press releases, no interviews, and no ribbons being cut. The work just started. It went on for 24 hours a day. Under the blinding sun and the cold desert stars, the machines never stopped. Excavators shaved off layer after layer of sand, digging a trench that stretched toward the horizon. Locals in the area reported hearing a low rumble beneath their feet, a constant vibration that meant something massive was being installed. Rumors started flying instantly. Was it a tunnel, a new defensive line, a military bunker? In this part of the world, when you see heavy equipment near a border, you assume the worst. Everyone was on edge. The location was critical. This was the Gaza border, a place where every 100 feet is monitored by drones, satellites, and watchtowers. Yet this project moved forward with a strange kind of immunity. When the work was finally done, the desert floor was covered up again. The heavy machines packed up and left as quickly as they had arrived. To the naked eye, the desert looked the same. But on satellite images, something new had appeared. A distinct strip running along the border, cutting through the landscape like a scar. It was a pipeline, and it wasn't empty. In August, the valves were opened. But it wasn't oil or gas flowing through these veins. It was water. Egypt had effectively connected the sea to the desert. They called the project Chivalrous Night 3. On paper, it was presented as a purely humanitarian effort to help the people of Gaza. But the way it was built tells a different story. It had all the markers of a covert operation. Guarded convoys protected the materials. Inspections were rigorous at every single segment. The press was kept far away. And get this, the pipeline is completely autonomous. It is cut off from Israeli networks. It runs on its own power, its own logic, and its own supply chain. It acts as if it wasn't made just for aid, but for strategic independence. The pipeline itself is a beast. It stretches about 4.7 miles across the sand. That might not sound like a long distance, but in a zone filled with conflict and rubble, laying 5 miles of pipe is a nightmare. The capacity is staggering. More than 2 million gallons of water can be pumped through this system every single day. It connects directly to the Al Buhaira Reservoir in Khan Yunis, which acts as a giant holding tank for another 1.4 million gallons. The engineering here is clever. The pipes run from the Egyptian border, hug the coastal road of Gaza, and terminate right near the major population centers. This setup allows the desalination plant in Rafah to push its limits. Before this pipe existed, the plant was capped at a certain output. Now, with this new artery, it can boost capacity to nearly 2.6 million gallons a day. Things used to be very different. For decades, most of the water in this region came from Mikarot, the Israeli state water company. The rest was pumped from local wells that were slowly drying up. This new project changes the game. It is designed to provide about 4 gallons of drinking water a day for every single person in the area. But it is not that simple, though. 4 gallons sounds like a lot if you are just thinking about drinking a glass of water. But that 4 gallons has to cover everything: drinking, cooking, washing, cleaning. In the emergency standards of humanitarian aid, 4 gallons is the absolute bare minimum for survival. It is the red line between life and dangerous dehydration. Right now, the reality on the ground is much harsher. Most people are surviving on between 0.8 and 1.3 gallons a day. Try to imagine that. That is less than 2 standard soda bottles of water for an entire day. You have to choose between washing your hands to stop disease or drinking enough to stay awake. And this is happening in one of the most crowded places on the planet. We are talking about more than 5,000 people packed into every square mile. It is a sea of tents, ruins, and people all competing for the same drop of liquid. Since the conflict escalated, the population dynamics have shifted, but the density remains crushing. The destruction is visible everywhere. Homes are gone. Roads are gone. But the invisible destruction is the water network. It has been obliterated. Behind the rubble lies a disaster that is older and scarier than the bombs. The water in Gaza is simply disappearing. But digging a pipeline is one thing. Finding water to fill it is a terrifying problem. The 97% pollution rate. The crisis here is not just about thirst. It is about poison. Usually when we hear about a humanitarian crisis, we think about food shortages or a lack of medicine. But here even the dirty water is a luxury. Clean water is basically a myth. The only natural source of fresh water in this entire strip is the coastal aquifer. Think of it as a huge sponge made of rock and sand sitting deep underground, holding ancient rainwater. For years, about 98% of all the water used here came from that sponge. The other 2% was bought from outside. But here is the catch. That aquifer was never meant to support millions of people. It is being pumped at triple the rate nature can refill it. Imagine a bank account where you withdraw $3 for every $1 you deposit. Eventually, you go bankrupt. That is exactly what happened to the ground here. The aquifer can safely give about 15 billion gallons a year, but people are extracting more than 50 billion. The result is catastrophic. As the freshwater level drops, seawater from the ocean seeps in to fill the void. Sewage from the surface leaks down. Today, 97% of the water from that underground source is unfit for human consumption. It is salty, dirty, and dangerous. Since October 2023, things have gone from bad to impossible. More than 80% of the entire water infrastructure has been destroyed. We are talking about the physical pipes, the pumps, and the cleaning stations. 2 years of conflict have turned a shortage into a collapse. Fuel is restricted, and without fuel, the pumps don't work. Without electricity, the desalination plants shut down. Even if there is water somewhere, the pipes to deliver it are shattered. Main lines are ruptured, leaking precious liquid into the dust. Underground sources are now polluted with rubble and chemicals from the war. 60 main wells have been demolished. It is a total system failure. Today, nearly 2 million people are living in temporary camps. There are no sewage systems. There are no taps. People walk miles under the sun just to fill a plastic jug with yellowish water. So, when Egypt started digging that trench, it seemed like a miracle. But wait, doesn't Egypt have water problems of its own? Yeah, about that, Egypt is actually in a massive water crisis. The country consumes way more water than the Nile can provide. The population is exploding, the climate is getting hotter, and the Nile is shrinking. Egypt has been screaming for years that they are on the brink of thirst. They are terrified of the Grand Ethiopian Renaissance Dam. This is a giant concrete wall built upstream on the Blue Nile by Ethiopia. Egypt relies on the Nile for 97% of its water. They believe that if Ethiopia fills that dam too fast, Egypt will turn into a desert. President El-Sisi has even hinted that this is a matter of life and death, suggesting that conflict could break out if the river flow drops. They point to old treaties from the colonial era that say Egypt owns the rights to the water. But Ethiopia says those treaties were signed without them. It is a massive diplomatic standoff. So, if Egypt is so scared of running out of water, how on earth can they afford to send millions of gallons to Gaza? It seems like a contradiction. Why would you give away your most precious resource when you are terrified of losing it? The answer is surprisingly simple. They aren't giving away their water. Egypt isn't financing this pipeline, and they aren't tapping into the Nile for it. The whole system works differently. The water flowing into Gaza actually comes from the sea, processed by a brand new desalination plant funded by the United Arab Emirates. It stands right on the Mediterranean coast, just a few minutes from the Egyptian border. The plant sucks in seawater, forces it through high-tech filters to remove the salt, and sends it through those secret pipes. Egypt loses nothing. Their fresh water reserves stay untouched. The sea has plenty of water to spare. But the Emirates aren't just building a pipe, they are running a massive logistics operation called Chivalrous Knight 3. This isn't just about laying a tube in the sand, it is about rebuilding a civilization's basic needs. The UAE started by fixing old networks in the north. They repaired wells, fixed pumps, and tried to get the grid moving again. Their goal is to reduce pollution and stop the spread of disease. They have built 6 desalination plants in the Egyptian city of Rafah. Together, these plants produce 1.2 million gallons of water a day. To date, they have delivered nearly 130 million gallons. It is a staggering amount of liquid moved into a war zone. And it is not just pipes. They are drilling new wells, including deep artisan wells that tap into lower reservoirs. In May 2025, they launched the 4th stage of this plan, repairing 28 broken wells. But let's look at the bigger picture. This is expensive, extremely expensive. Who pays for the maintenance? Who pays for the electricity to run the pumps? Right now, it is all aid. But imagine if the UAE decided to stop giving it away and started selling it. This water could eventually become the most expensive commodity in the entire region. Taiwan's secret underwater lifeline. What if this humanitarian project turns into a business? It is not as crazy as it sounds. In a commercial model, people would have to pay for every drop. Either they buy a ticket to fill a canister, or the local government pays the bill using taxes. We actually have a blueprint for this. Look at the Turkey-Northern Cyprus water pipeline. This is an engineering beast. Completed in 2014, it delivers fresh water from southern Turkey all the way to the island of Cyprus. It is the only underwater pipeline of its length in the world. Cyprus, like Gaza, was drying up. Rainfall dropped by 2.5 inches over 70 years. The groundwater was vanishing. So they built a plastic snake that dives 820 feet under the sea and stretches almost 50 miles. It pumps 20 billion gallons a year. But it wasn't free. When the water first started flowing, it was sold. Turkey made money. The municipalities in Cyprus sold it to residents with a markup. By 2022, the price had tripled. But everyone paid it because the alternative was having no water at all. Both sides won. Turkey got revenue and Cyprus got to survive. Then there is the example of Kinmen Island and China. Kinmen belongs to Taiwan, but it is incredibly close to the Chinese mainland. They were running out of water, pumping their underground reserves until they were salty. Building a desalination plant was too expensive, so they struck a deal. Now water flows from mainland China through an 11-mile underwater pipe. It cost the islanders about 32 US cents for 260 gallons. It works. It is efficient. And it proves that countries can strike water deals even when politics are complicated. But Gaza is a different beast. The commercial approach won't work here right now. The local authorities are broke. The people have lost everything. You cannot charge a family for water when they don't even have a roof over their heads. That is why the UAE is footing the bill. If they tried to sell this water, the global backlash would be instant. It would look like war profiteering. So for now, the water flows as a gift. But history shows us that eventually infrastructure tends to become a business. When the dust settles, someone will own the tap. But let's get back to the science. How do you actually turn the sea into drinking water? The process is called reverse osmosis. Basically, you take seawater and push it at incredibly high pressure against a special membrane. Think of it like a superfine screen. The water molecules are small enough to squeeze through, but the salt and dirt are too big, so they get left behind. The result is crystal clear fresh water. But what happens to the salt? It doesn't just disappear. It stays behind in a super concentrated sludge called brine. And get this, for every gallon of fresh water you make, you create a gallon of this toxic, salty slime. Most plants just dump it back into the ocean. They try to dilute it, but the sheer volume is mind-blowing. Recent studies show we are producing 50% more brine than we thought. Imagine covering the entire state of Florida with a layer of salty sludge 12 inches thick. That is how much brine we make every single year globally. The plant supplying Gaza is adding to this pile. 55% of the world's brine comes from this region: Saudi Arabia, the UAE, Qatar. They live off desalination, but for nature this is a nightmare. The brine is heavier than normal seawater. When you dump it, it sinks straight to the bottom. It spreads out across the ocean floor like a thick, suffocating blanket. It kills the oxygen supply. It wipes out algae, corals, and small fish. It creates underwater dead zones where nothing can survive. The Mediterranean is already fragile. It evaporates faster than it fills up. It is naturally salty. Adding millions of tons of brine makes it even saltier. We don't know the long-term damage yet, but we are running a massive chemistry experiment on the ocean, and we might not like the results. But there is a much more immediate danger than salty sludge. The pipeline runs through a war zone. The risk of it being blown up is not just a theory, it is a daily reality. One misplaced airstrike could turn this lifeline into a catastrophic flood. One crack away from total collapse. The Israeli Air Force strikes targets in Gaza with a frequency that defies logic. During the absolute peak of the conflict, the sky didn't just rain fire, it poured it. Everything was hit. We aren't just talking about military bunkers. We are talking about hospitals, schools, major intersections, the very fabric of the city. Statistics tell us that more than 70,000 tons of bombs were dropped on this tiny strip of land. Let that number sink in for a second. 70,000 tons. To put that into perspective, that is more than the combined tonnage dropped on Dresden, Hamburg, and London during the darkest days of World War II. Now imagine the ground beneath your feet absorbing that kind of punishment. The shock waves don't just stop at the surface. They travel down. They rattle the bedrock. They turn soil into jelly. And right there, buried in this shaking, burning earth, lies a single plastic pipe. In these conditions, an underground plastic pipe is about as safe as a glass house in a hailstorm. Yes, the engineers will tell you it is buried. They will tell you it is shielded by layers of sand and concrete. But let's be real, it is not deep enough. Modern warfare uses bunker busters. These are munitions designed to punch through 6 feet of reinforced concrete before they even explode. A plastic water pipe? To a bunker buster, that pipe doesn't even exist. It's paper. One powerful hit nearby, not even a direct hit, just nearby, and the shockwave alone could shatter the pipe into a million pieces. But here is where the theory gets dark. Some experts suggest this fragility isn't an accident. If you cut the power, people can survive. If you cut the internet, people are blind. But if you shatter the water main, you don't just stop a resource. You create a localized disaster that rivals the bombing itself. We don't have to guess what happens when a high-pressure water main bursts. We have seen it, and it is terrifying. Look at what happened in Karachi, Pakistan in April 2025. This wasn't a war zone. This was a normal day. A massive water pipe 72 inches wide, that is 6 feet, big enough for a grown man to stand up inside, suddenly ruptured near a university. It wasn't a leak, it wasn't a drip, it was an explosion. Witnesses on the ground said it sounded like a jet engine taking off. The ground literally opened up. A torrent of water gushed out with such force that it stripped the asphalt off the road. It flooded streets within seconds. It smashed into homes, blowing out windows and doors. It swept away cars like they were toy boats in a bathtub. People described it as a tsunami coming out of the ground. It took the authorities hours to find the manual shutoff valve. By the time they stopped the flow, entire neighborhoods were ruined. Foundations of houses were cracked. The city faced a massive shortage for weeks. Now take that image, that wall of water, that destruction, and transport it to Gaza. The new pipeline runs right near the coastal road. This is the exact area where thousands of refugees are currently living in makeshift tents. They are sleeping on the ground. They have no protection. If that pipe bursts under high pressure, it wouldn't just make a puddle. The physics of a burst at that PSY, pounds per square inch, are catastrophic. It would blast through the sand like a geyser. It would turn the solid ground into a liquid death trap. It could wash away hundreds of tents in a matter of seconds. It would destroy the few remaining roads used for aid trucks, and in the grim darkness of the night, it could drown people who are sleeping on the ground before they even knew what hit them. But here's the thing that keeps paranoid engineers awake at night. It doesn't even need a bomb to break. Pipes fail. It happens all the time, but sometimes the failure is so strange, so unexplained, that you have to look at the wilder theories. Look at Greece. On the island of Aegina, they had a state-of-the-art underwater pipeline delivering fresh water. It was their lifeline. Then, one day, it just stopped. No warning, no storm. The water pressure hit zero. Everyone immediately thought it was sabotage. The locals blamed rival water truck companies. The government blamed terrorists. Divers were sent down to the seafloor, diving to a depth of 160 feet to inspect the line. What they found was baffling. The pipe hadn't been blown up. It had just cracked. It was a clean break. The official report blamed stress and pressure, or maybe a manufacturing defect. But the fringe theorists pointed to something else. They talked about resonance weaponry. This sounds like science fiction, but the concept is real. Every object has a natural frequency. If you hit that frequency with sound waves or vibrations, the object destroys itself. We've all seen a singer break a wine glass with their voice. Now apply that to infrastructure. Could a specific frequency emitted from a drone or a passing ship cause a hardened plastic pipe to shatter underwater without using a single explosive? That one crack in Aegina left 13,000 people without water instantly. They had to scramble to find emergency supplies. It showed the world just how vulnerable these lifelines really are. When you rely on a single tube for your survival, you are always one accident or one frequency pulse away from total disaster. In Gaza, the danger goes deeper than just a lack of water. The soil itself is a weapon waiting to be triggered. Gaza is built largely on sand and sandstone. It's porous. When a high-pressure pipe bursts underground, the water doesn't always shoot up. Sometimes it shoots out. It saturates the soil deep underground. This creates a phenomenon called soil liquefaction. Imagine standing on dry sand. It's solid. Now imagine water rushing through that sand from below. Suddenly, the friction between the sand grains disappears. The ground turns into quicksand. If this happens under a road, the road vanishes. If it happens under a building, the building tips over and sinks. Now combine this with the heavy aid trucks. You have massive 18-wheelers carrying tons of flour and medical supplies driving over these roads constantly. The vibration is immense. The weight is crushing. If the pipe beneath them leaks even a little bit, creating a pocket of mud, the next truck that drives over it could punch right through the crust. We are talking about massive sinkholes opening up in the middle of a refugee corridor. Some theorists believe this isn't just a risk, it's a calculated strategy. A sinkhole trap. Think about it. If you wanted to stop aid trucks without firing a missile, how would you do it? You destabilize the road. You make the ground itself impassable. A natural disaster caused by a broken pipe is the perfect cover. No one gets blamed, it's just bad maintenance. But the result is the same. The supply line is cut. If the pipe breaks, the water stops. It is binary, on or off, life or death. And in Gaza, if the water stops, the clock starts ticking very fast. There are no reserves. There are no giant water towers filled with backup supplies. The aquifers are salty and polluted. This is the crazy part. We are looking at a project that is saving thousands of lives every day, yet it hangs by a thread. It is a marvel of engineering surrounded by absolute destruction. It is a symbol of hope that pumps sweet, fresh water from a sea filled with warships and submarines. But is it really just water? There is a wild theory circulating on the dark corners of the web called the Trojan horse liquid. We know that modern desalination plants are incredibly advanced. They filter out salt, bacteria, and impurities, but they also add things. Minerals, chlorine, fluoride. The theory goes like this: if you control the water source, you control the biology of the population. What if the mixture isn't just for hydration? What if there are additives designed to induce lethargy? To lower aggression? To weaken the immune system over time? It sounds insane. It sounds like a movie plot. But history is full of governments using resources to control populations. In the 1960s, the CIA experimented with dosing water supplies with LSD. In modern conflicts, biological warfare is often delivered through liquids. When the enemy controls the tap, you have to trust that they are only sending water. But in a war where trust is non-existent, every sip becomes a gamble. Let's go even wilder. Let's talk about the ground itself. We mentioned the bombing tonnage earlier, 70,000 tons. Geologists have noted that intense, concentrated bombing can actually shift the local water table. It compresses the aquifers. It changes the flow of underground streams. Some researchers believe that the intense vibrations from months of bombardment have created microfaults in the limestone beneath Gaza. These are tiny cracks in the bedrock. Now you introduce a high-pressure pipeline. If that pipe bursts and injects millions of gallons of water into these fresh microfaults, you could theoretically trigger a localized seismic event. It's called induced seismicity. We see it in fracking operations all the time. When you pump liquid into the ground under high pressure, you lubricate the fault lines. You cause earthquakes. This pipeline is a temporary fix for a permanent problem. But with the region so unstable, do you think relying on a single pipe is a brilliant move or a disaster waiting to happen? Let me know in the comments. If you learned something new, hit like and subscribe for more deep dives. Thanks for watching.